Hello ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. You're welcome to Mr. Do Scienceworld. And today we're going to deal with calculation of two-dimensional projectile motions. So we want to look at the calculation. The last time we looked at the concept itself, but today we want to deal with what real problem solving. So we want to solve problems on two-dimensional projectile motions. So let's remind ourselves of certain things here. I have said to you earlier that if you're dealing with 2D projectiles, okay, so 2D projectiles. Alright, and if we're dealing with 2D projectiles, there can be three types that we can see. Okay, we can see three types. The first one that we can see is we can see a situation, okay, where we are having like a cliff, okay, and if you have a cliff like this and you see an object being dropped from the cliff, so that you see something like that. Okay, let me try and give it more curve. So we'll see just something like this. Right, good. So we will see something like this. This is one kind of projectile motions that we can see, okay, and we will look at them from a certain angle. So we can see that there is an angle in which this is being dropped. All right. We can also look at it from another point where we will see it, okay, on the cliff again, but this time around the projectile went up, okay, so we have it from there, and then it goes up and then returns back again to there. So we can also have something like this, okay, and in this case again we still see there is a certain angle theta there. Like here we have the angle theta there, right? So the initial velocity is there, and then here is that we have it that way. All right, now remember something here. Object is being dropped, so we can see the initial velocity is going to be what? It's going to be 0 from there. And then this is the first one, this is the second one, and the third one that we can have is a situation where we see that, okay, maybe the thrower is on the ground and then projects or launch an object up and goes up like that and then returns back into the ground. So we can also have something like this. Okay, and in this case again we can see there is a certain angle that this is being what? Is being projected. So we can see this is the third part that we can see. In each of these cases we can deal with the calculations from there, and that is the kind of problems that we are going to solve for today. So whether the object is being dropped or the object is projected, went into a certain height and returned back into the ground on a cliff, or the person stands on the floor just like I am here now, and then I throw it and it goes up and then return back again into the thrower, or goes back into the ground. So we can have all these three situations to solve problems. And what we are dealing with is two-dimensional projectiles. So let's look at the first problem that we will have for the day. All right. The first problem, let's go straight away and look at the question. And the question says a projectile is shot at time t equals to 0 from the edge of a cliff 115 meters above the ground level with an initial speed of 65.0 meters per second at an angle of 35.0 degrees with the horizontal. And the question is asking, draw a diagram for the problem showing the trajectory of the projectile. Then answer the following. Question number 1. How long will it take the projectile to reach the ground? How long will it take the projectile to reach the ground? Right. The first thing to do is remember that there was a cliff and we were told that the ball was what? Thrown vertically what? Upwards. The projectile was shot what? Upwards, and then it returned back into the ground. So we're going to have like the second picture that I showed you, the second graph. So we're going to have something like this, where we'll have the graph from here, and we can see the object is from this point, it went up and then returned back to the ground like this. All right, good. So this is how our graph is going to look like. And then we can see that we were told by the question that there is an initial velocity. So the initial velocity, pardon me, just put it this way here. so that you can see, and that was what? 65.0 meters per second. And the angle that it makes is what? Is 35.0 degrees. Right. And the height of the cliff, according to the question, the height of the cliff is what? Is 115 meters. 115 meters. So we have these. This is the sketch that we should have. And remember, this is our y-axis and this is our x-axis that we have. This is the picture of what we have. And the first question is asking, how long will it take the projectile to reach the ground? How long will it take it to reach the ground? You move from here, the projectile was shot from this point and went up and then returned back into the what? Into the ground. Okay. So if I've gone up and returned back into the ground, we want to see how long. The word how long speaks to us about what? The time. So it means we want to look at the time taken for the projectile to be launched into the space and return back into the ground. So let's see. Remember that the initial velocity is what? Is at a certain angle. That simply means that this initial velocity is having what? Two components. That is the x component and the y component. So we can see that if I resolve from here, this point now, I am going to have the y component as well as the what? The x component. So if I form a right angle triangle from there, which with the angle 35.0 degrees, I can simply find the what? The initial velocity in the x direction. And remember, in the x direction, that is the what? That is the adjacent. And therefore, if it is adjacent, we're going to have the v naught what? Cos theta. And that becomes the what? The how we can determine the what? The x component of the initial velocity. We can also find the what? The y component of the initial velocity. And that is also going to be, here is the opposite. So we make use of what? The sign. And that's going to be what? V naught sine theta. And what is our theta? Theta is what? It's 35.0 degrees. And what is V naught? Our V naught is what? It's 65.0 meters per second. Alright. We want to find the time it will take the what? The projectile to return back into the ground. What do I do? Which formulas do I need to use? Remember, we have to make use of what? Equations of motion. So what type of equation of motion am I going to make use of? Okay, I am going to make use of change in y. Change in y equals to v, okay, I t plus half gt squared. All right, now this is the formula that I'm going to make use of in doing the calculation. What is this vi? The initial velocity, remember, the projectile went up and then returned back into the ground. So the velocity that is keeping the what? The projectile upward is the what? Is the y component, not the x component. The x component will only enable the projectile to move what? Horizontally. But in this case, we're looking at the vertical motion. So we have to consider the what? The y component. So this will simply become change in y is equals to vyi t plus half gt squared. And what is the vyi? It is what? V naught sine theta. So I can simply say that this will therefore become what? V naught sine theta plus half gt squared. And what I want is to find what? Is to find my what? To find the t. We were given the what? The change in y. The projectile was started from here, it went up and then returned back into the ground. Okay, so the initial position is here, but look at one interesting thing here. If I draw a line like this across here and divide this projectile in this direction, you can see that the distance from here to here is the same as from here to here. And remember, displacement is a vector quantity, so it has what? Magnitude and direction. So if I take from here going to be positive, then from here to here is going to be what? Negative. So it means from here to here is equal to from here to here, but they are opposite in each other. That will be cancelled out, and what we'll be left with is what? Is just here, which is the what? The change in y, which is on the side, and that is the what? 115 meters that we were given. So that is the value that we are going to use for the change in y, and we are given our what? Our v naught to be 65.0 meters per second, and our theta is given to us as 35.0 meters, 35.0 what degrees. And we know g. What is g? G is 9.8 meters per second squared. Right. I want to take the direction of motion and do the calculations from that point. So I will take my direction of motion and say that, okay, upward motion is positive. That means that any of the quantities that is going up is what? Is positive. And if that is established, then we can do the substitution into that. Change in y is going down, so that should become what? Negative 115 is equal to what? V naught is 65.0 multiplied by sine 35.0 degrees plus half. G is always acting downwards, so that should become what? Negative, and that's going to be what? Negative 9.8, and we are going to multiply that by what? By our t squared. So what we have is t, the value is not known, so t squared. Oh, remember here there is a t that we have left out. Okay, let me clean the board and give more space for that. So we will have negative 115 is equals to 65.0 multiplied by sine 35.0 degrees, okay, multiplied by t, and then plus half multiplied by negative 9.8 multiplied by the t squared. Right. Once we have this, let's check it and see what we are going to have. You see, we're going to have a quadratic equation. So okay, so what we need to do from here, I'll just take my calculator and I punch that into it, and I'm having negative 115 is equals to, when I punch this, I am having 37.2824. Okay, let me make it 2825t. I leave it in 4 decimal places so that I'll get an accurate result, and then plus what this multiplied by that should give me negative value, and that's going to be 4.9, right? So because what we have is 9.8 divided by 2, and that is given as 4.9. So we have 4.9 t squared, right? Now 4.9 t squared, what do? I will transpose this, and I see that I'm having 4.9 t squared, and I'm transposing this to the side, okay, all these to the side, because I want this to become positive. So I'm getting this will go there and become negative 37.2825 t, and this is already here, negative what? 115, and that must be equal to what? 0. One beautiful thing we can see, this has become what? A quadratic equation. And once we have a quadratic equation like this, we can solve by the quadratic what? Formula. So let's use the quadratic formula and see what we're going to have. If I use the quadratic formula straight away and do the substitution into this, okay, we can use the calculator to solve this. So I am just going to use the calculator to solve this, but I can use the quadratic formula and say t is equals to negative b, okay, negative b plus or minus root of b squared minus 4ac all over 2a. And then with this, you do the substitution into this and solve for what? And solve for your t. If I do this from here, the substitution, t is now equal to negative, and where is b? B is the coefficient of t, and that is also negative 37.2825t, and plus or minus root of what? B squared is the whole thing there, negative 37. I need more space, so let me clean that side and put that values there. so that I can have more space. So I clean the side so that we can have more space and put the right values. Right. So let's do the substitution. We have t is equals to negative into negative 37.2825, okay, plus or minus the root of what? B. So that is also negative 37.2825 b squared minus 4 multiplied by a. What is our a? What is our a? If we look at a is the coefficient of t squared, so that is going to be what? 4.9. And then we will multiply that by c again. And what is c? Our c is also the constant. That's negative 115. And all over 2a, which is 4.9. And if you solve for this, automatically we expect to have two answers. And what are the two answers that we are going to have? Well, we're going to have t is equals to 9.96 seconds, or we're going to have a negative value which is negative 2.36 seconds. So these are the two values that we are going to have. But now let's check something here. We are going to pick the positive value. We're going to pick the positive value because at this point here, we want to look at the time that the object is returning back into the ground. And if the object is returning back into the ground here, we expect the value to become what? To become a positive answer. Therefore, the right answer to this problem is the time is equals to 9.96 seconds. And that is going to be the time that it will take the projectile to move from the point of projection into the what? Into the ground. Alright, in case you're still confused about why I chose the positive time and not the negative time, what you have to understand is that according to the question, we were told that the projectile was launched at what? At t is equals to what? Equals to 0. So if it is at t equals to 0, therefore our time cannot be what? Negative. And that is why we have to pick the what? The positive value. Alright, let's move on to question number 2. What is the question number 2 saying? Question number 2 is saying, at what distance from the base of the cliff where the projectile hits the ground? At what distance from the base of the cliff where the what? Projectile hits the ground? Right, so let's look at that and see what actually the question is looking for. The question is looking for a distance, but what distance is it looking for? Is it looking for the maximum height? It's looking for what? The range? Or is it looking for the total what? Displacement or the total distance? Let's look at it and see. Okay. We are looking from the point where the projectile was what? Was projected till it reaches the ground. And if that is the case, therefore, our interest is to calculate for what? To calculate for the range. So it means it wants us to calculate from here to this point. So here is what we are looking for. So we're looking for what? What do we call the range? And the range here is the what? Is the change in x, because that is the what? A horizontal motion. So if it is a horizontal motion, it means we're looking for change in x. And remember, range is now the same as the change in what? In x. And now let's see what is going to be the change in x. The change in x now is just going to be what? The vxi multiplied by what? T. What is this t? The t is the total time, because it started from here, which is equal to this side, and now it is here, so the total time is what we are making use of. And that is what we have already calculated and got what? 9.68. Sorry, 9.96, right? Okay, that's what we got as our value. Remember, I want to do the calculation. That 9.96 seconds, this is the approximated value. So if I want to do the calculation, I shouldn't use the approximated value. I should use the actual what? The actual time. And then when you use the actual time, you are going to get what? The exact value that is expected of us to have. So let's check it and see what we should have. Alright. If I do that and I go by this, what is this Vxi that I'm going to make use of? The Vxi is the what? Is the x component of the what? Of the velocity which we have what? We have already worked with before. That is the what? The initial velocity in the x component. And remember that is what? V naught cos theta. So let's go on and make use of that. So change in x can simply become V naught, okay, so V naught cos theta multiplied by what? The time. And now I am going to do the substitution from there. So this is straight away going to give me what? V naught is 65.0 multiplied by cos 35.0. And then the time I'm going to make use of the, I know right now the approximated value that I was having. So if I punch that again into the calculator, then we make use of that time, like 9.96, certain values that were there. And if I do by that calculation, what should I have? What we are going to have, we're going to have a value which is what? 531 what? Meters per second. Sorry, 31.51 meters what? So this is 531 what? Meters. This is the change in x. The value we're going to have is this. You're going to have this value straight away. After putting that into the calculator, if you make use of just this value, you're going to have a value which is just going to be maybe 530 point something. And when you do the approximation, then we're going to have this value. Alright, we can leave our answers in 2 decimal places, which is always preferable. For me, I always prefer to leave my answer in what? In 2 decimal places. And if I leave my answer in 2 decimal places, we are expected to have around 350.57. So that if I approximate, then I'm going to have what? This value that I have here. So this is what you're going to have. Right, so that is your answer. Right. Okay, let's check and see. So this is what the distance is going to cover from here to this side. That is the distance. We have calculated that and then we got this value. Let's move on and do the next question. The next question is asking, at what speed will the projectile hit the ground, and at what angle from the what? From the horizontal. So here we are looking for the magnitude of the what? Of the velocity, as well as the what? The direction in which it is going to what? Is going to go. So we're looking for both magnitude and the direction. If I'm looking for the magnitude and the direction, what do I need to do? What I need to do is that first, remember here, we are talking about the velocity at this point, okay? Because the question says, at what speed will the projectile hit the ground, and at what angle from the what? From the horizontal. So if I'm looking for that, we are looking for just the velocity just before it hits the ground. And the velocity just before it hits the ground, there are going to be 2 components there. Remember, we're going to have the x component, okay? The x component of that velocity is going to be here. So let me call it Vxf, okay? And we are going to also have what? The vertical component, just like that. Okay, so that is also going to be what? Vfy or Vyf. There's the final velocity in the y direction, and then the final velocity in the x direction. This, we will find this and find this, and what the question is actually looking for is the resultant. That is what we want to look for. So which is the v or the vf. That is what we are looking for. So if that is what I am looking for, then I need to find the vx, okay, the vx final, and then the vy final. How do I find the vx final? Well, remember that in our last video when we spoke about the 2D concepts, we said that the x component does not what? Change. So the x component is what? Is constant, which means that in this case, the value of the x component is not going to what? Is not going to change. It's going to remain what? The same. And that is, it means from here, the value of the x component is the same as the value of the s component here. So we're going to say that our Vx final is now going to be our V naught cos what? Cos theta. And that is what? 65 cos 35.0 degrees. That is it. That is going to be our Vx final. Okay. And if we do this, let me punch the calculator and let's see what we're going to have as our value. So 65.0 multiplied by cos what? Cos 35.0, and that is going to give me 53.244888 that. Right, I'm going to write all the values because if I'm doing the calculation, I prefer to use, at least let me put 4 decimal places so that I will get an accurate result. So I'll have 53.2449. Alright, that is the velocity. And that is the final velocity in the what? In the x direction. Final velocity in the x direction. Now let's look for the final velocity in the what? In the y direction. How do I calculate for that? Well, I can simply make use of the formula to say V final is equals to Vi plus GT. Plus GT. And then I'll be able to do what? To find out. Because I already know the time there, and I know G, I know the what? The initial for the what? For the y component. So I can find the final for that. Alright, so I am going to do this. So I'll transform this and make it like it is V y final is equals to what? V y initial plus GT. And this is what I need to make use of the substitutions and solve for the what? For the problem. So now I am going to solve for that. Quickly, let me clean up and solve for that problem. If I do this, let's check it and see. We put in the value. What we want is this, so let's put the values there. Vy final is equals to this. I am taking my upward motion as positive, okay? So here the y initial was going up, and that is the value which is going to what? 65.0, okay, multiplied by sine what? Sine 35.0 degrees plus this is going downward, so that is what? Negative 9.8, and then we are going to multiply it by what? By the time for us to do the what? The calculation. Alright, so the time is, let me try, I think the space is still not enough, so let me come here. VYF is equals to, what we have is 65.0 multiplied by sine 35.0 degrees, okay, plus negative 9.8, and then we multiply it by the time, it is 9.96, okay, put the full values there. Right, and once we do that and we multiply all these together, what are we going to have? We are going to have a negative value, and that is negative 60 point what? Point negative 60 point, let's see, negative 60, punch it into the calculator. Okay, let me do that quickly and see. Alright, cool. We have negative 60.34, okay, meters per second. And that has become the what? The VYF. And we have already found the what? The VXF, which is here. So now we found the X component, we found the Y component. I need to draw a vector diagram and do the calculation. So to draw the vector diagram, remember something. Let's see from here. Okay. I want it here and then find the vector diagram. Draw the vector diagram and do the calculation. So if I draw a Cartesian plane like this, okay, here is the positive y, here is the negative y, okay, here is the positive x, and here is the negative x. and the value of the x component is what? Is positive. So that means that we are here, and the y component is what? Is negative. So it means we have to fall into this quadrant. So the y is here, and then our x is there, and we are going to then quickly find that value. So I'm going to draw it, and then my graph is just going to look something like this, and then we have it something like that, and I am just going to do this. So what we want is this VF. We know this value, which is what? 53.2449 meters per second, and then this one is now given to me as negative 60. You can write negative value, or you leave the negative value there, because remember, the negative sign is telling us the direction which you have been able to locate the quadrant in which that value or the diagram falls into. So negative 60.34 meters per second. All right, good. I need to find this, so straight away we know we can make use of our Pythagoras theorem, and then we're told to find theta. So theta will lie here, because he said we should find theta with with the horizontal, and there's the horizontal. So this is the angle that we are interested in looking for. So if that is the angle we are interested in looking for, then let's go ahead and find our VF. Okay, so if you use Pythagoras theorem, then we will say that it is VF squared is equals to what? V x f squared plus V y f squared. And that simply implies our VF is equals to the square root of VXF squared plus VYF squared. And now we will do the substitution from here. So let's do substitution. Substitute the values into this. And if you substitute the values, somebody will ask, am I going to substitute it with a negative value? Yeah, I'll put in the negative value, because remember, if you put in the negative value and you square it, it becomes positive. So that is not going to affect your result. If you leave it, that's also okay. But just to know exactly what you're doing. So there's 53.24 squared plus, let's put that one, this is negative 60.34 squared. And let's punch that into our calculator. Quickly punch that into the calculator. So we take our calculator, and then we're going to do the calculations from there. This is root of what? Root of 53.24 squared plus negative 60.34 squared. And then let's see, what are we getting? We're getting in 80.46. So once you do this, we are getting the value to be 80.47. And this is velocity. So I'm going to leave it as meters per second. I leave it answer in two decimal places. I've gotten the final velocity. It means that it's going to take 80.47 meters per second to reach the ground. That is the speed with which the projectile is going to move. Now let's find the direction. What direction is it going? Right? Theta is what we have to look for. So if I have to look for theta, let's see how to go by calculating for theta. If you want to calculate theta, this is trick. So I have the opposite against the adjacent. So I can make use of my tan, and that is tan theta is equals to VYF all over VXF. And then let's do that quickly. So this will simply become, we're going to do the substitution. So theta is now arctan. The arctan, or the tan inverse of what? Of the values that we were given. That is negative 60.34 divided by 53.24. And then let's check it and see what are we going to get for our answer. We're going to have negative 48.58 degrees. And this is the angle with which the projectile is going to move here with the velocity that is used in reaching the ground. So the velocity here, the velocity is 80.47 meters per second at an angle of negative 48.58 degrees. Alright, so let's look at the next question for this particular problem. And the next question says, how high were the highest points of the trajectory? How high will be the highest point of the trajectory? How high will be the highest point of the of the trajectory? Alright, so when we look at it, already we were given 115 meters. Okay, so we need to find the maximum height, right? And then we will add that to this, and that will give you how high will be the point of the trajectory. So because like we're looking from here to here, and already we know from here to here, so we need to find from here to here and add that to this, and that will give us how high it is. So let's quickly start from there. Right, so for me to find the maximum height, remember that at the maximum height, our velocity, the final velocity at the maximum height is going to be is going to be 0, because the projectile is going to have a momentary stop. So straight away we will just make use of the formula Vf squared is equals to Vi squared plus 2g change in change in y. And then we are looking for this change in y, which is the maximum height. That's from here to here. That's what I'm looking for. And I know this is 0, and you know this one. Remember, the object is going up, so we still need the vertical component of the initial velocity. And I'm taking my upward motion as positive, and that means that is going to be 0 squared is equals to 65.0 multiplied by sine sine 35.0 degrees, and then all squared, because this is squared, so that is it, plus 2 multiplied by negative 9.8 multiplied by change in y. And then we need to do the calculation from here. So let's take our calculator, and then let's punch that into the calculator, and let's see what we are going to have. If you punch this into the calculator, let's try and just simplify something first before we do that. If I multiply this by this, it will give me negative value times this. So I'm going to transpose that. Multiply this by this, it will give me 19.6. So negative 19.6 multiplied by delta 8, and I'll transpose that. So that is going to give me 19.6 change in y is equals to all that value that we have there, multiplied by sine 35.0 degrees. And now let me divide through. So what is going to be my change in y? It's going to be 65.0 multiplied by sine 35.0 degrees, okay, squared, divided by what? Oh, here is squared, sorry, that's squared. So divided by 19.6. And let's punch this into our calculator, and let's see what we're going to have. Okay, so I punch that into the calculator, and then let's see what we're going to have straight away. Right. Okay, so once I do that, I am getting 70.9174718. So this is change in y is equals to 70.9174718. And I am going to add this value to that, so therefore I will say that the maximum height or change in y highest point, okay, is now going to be this 70.9174718 plus 115. And let's do that, and let's see what we're going to have. Plus 115 to that. And straight away we're getting 185.9174718, which I can simply, let me just call this one change in y total to make it simple. And that is going to become what? Approximately like this meters. So This is going to be the highest point of the what? From the trajectory to the ground. So we can see from here to here is going to be what? 186 meters high. Alright, let's look at another question. Let's look at another question. So let's look at the next question that we will have. Right. The next question is saying a canoe capable of firing a single shell in any direction at a speed v equals to 1.40.0 meters per second is placed on the ground. And the question is saying, in what angle shall this canoe be pointing in order to hit a target placed on the ground 1.000 kilometers away? Right. So let's look at this. If you look at the problem that we are given here according to the question, and we try to give a sketch, as I said, always give a sketch of the problem that you are given so that it will be very easy for you to do the analysis. I can say the projectile is going to be of this form. Okay, so it is going to be of this form. According to the question, we want to find how these should be angled. The angle here is what we are looking for. So our interest lies in finding this theta here. Because I think according to the question, our initial velocity is 140.0 meters per second. So here we have V naught being equals to 140.0 meters per second. That is the initial velocity according to the question. And we are given from here to here, which is the range. The range is also given, and the value of the range is 1.000 kilometers. And these can be equivalent to 1,000 what? Meters. Because this is in kilometers, we multiply by what? 1,000, and that becomes 1,000 what? Meters. Alright, so we are given the range, we are given the initial velocity, and we want to find the angle. How do we find this angle? Well, what I need to do from here is that, remember, this velocity is at a certain what angle, so therefore there is x component and there is what? Y component for that. So I can look at it to say that since I am given the range is obtained by saying change in y is equals to v x initial multiplied by what? T. And what is this t? T is the total time. T is the total time. Alright. Now let's check it and see from here if I have this as my t. We will go ahead and then I know of this. I can't find this value. So what is the next thing to do? I need to find what? My total time. I need to find the time taken. So if I want to find the time taken, then I can say change in y is now equals to v y initial, okay, vy initial multiplied by t plus half gt squared. I can use this to find what? My total time. And what is the change in y? Remember, I am moving from here to this side now. So if we divide this, remember the distance from here to here is the same as from here to here. And this is positive. If this is positive, this will be negative. If this is negative, this will be positive. And if they are equal in magnitude but opposite in direction, therefore our change in y will be equals to what? 0. And if my change in y is equal to 0, then I can equate this to 0. And then I will solve for my t. Alright. I am going to make use of the t because the total time, so let me make a capital T for that. And then solve for that value there. So if I want to solve for that, this is going to be 0 is equals to Vyi is now going to be V naught sine theta plus V naught sine theta multiplied by T plus half gt squared. And what do I need to do? This is equals to 0. There is t here, there is t here. I can factor out the t and solve for the problem. So if I want to factor out t, then it's going to give me 0 is equals to t out into v naught sine theta plus half g what? T. Half gt. Okay. So I have factored out t. So what is this going to be? So it is simply implies that from here I'm going to have t equals to 0 or all this equals to 0. These are the two solutions. So I will have t is equals to 0, where there's one part, and on the other part we're going to have v naught sine theta, okay, plus half gt is equals to what? Equals to 0. And here let me make t the subject from this point now. If I want to make t the subject, I'm going to multiply through by 2, so that if I multiply 2 by 2, I'm going to have 2v naught sine theta plus gt equals to what? Equals to 0. And I want to make t the subject, so I'll transpose this, so I'll have gt, or let me go straight away. I think from here you should understand that. So my t is now going to be what? Negative 2v naught sine theta divided by what? G. And that is the value of the t. Where is this t? That t is here. So I have found the total time taken, okay, to reach here. So I can straight away go ahead and substitute that value into what? The t, and solve for what? For the angle from there. Because I am given the what? The change in x, which is the what? The range. The range is given. Right. So we're going to do that. Remember, vxi is what? Is v naught cos theta. So if that is it, because this is the same as v naught cos theta, cos theta multiplied by the t, right here. Okay, good. So I am going to do that. I'm going to substitute this t value here into this particular function there. So what am I going to have? From here is going to be change in x is now equals to v naught cos what? Cos theta multiplied by negative value, which is this one. So I'm going to put in all that. Negative 2 v naught sine theta all over g. This. What can we say from here? Now something beautiful is coming out. Something beautiful is coming out. Change in x is here. So if I want to solve from here, if I multiply all these out, what am I going to get? I'll get change in x is now equals to negative 2 v naught multiplied by v naught will be v naught squared, and this is now sine theta cos theta all over what? All over g. Okay, I want to make the whole thing to become positive, because I know that the value of g is negative 9.8. So if I'm doing the substitution, I should have negative 9.8. So straight away, I'm going to make that to become what? Positive. Right. So I'm going to change all to positive, so that whenever I am doing the calculation, I am not going to use negative 9.8 for g, but I'll rather use what? Positive 9.8. So from there, I can say that this equation here is going to become change in x is now equals to 2 v naught squared sine theta cos theta all over g. Right, good. So now this has become positive, and I've explained to you why I'm making this positive. If I make it positive, then this negative sign is no longer going to be negative. It's going to be what? Positive 9.8. Now let's see. Something interesting is here. What is that? If you have your knowledge of trigonometry, we can see that I can say this is V naught squared into 2 sine theta cos theta divided by G. And what is this 2 sine theta cos theta? It is an identity. And that identity is what? That is sine 2 theta. So I can say that from here, this 2 sine theta cos theta is now equals to what? Sine 2 theta. So in place of this, I am going to put what? Sine 2 theta. So this will become, change in x is now equals to V naught squared, what? Sine 2 theta divided by G. And from here, I can now do the substitution. Why? I know the value of V naught. I know the value of G. I know the value of what? Of the x. Change in x. So I can simply solve for my theta from here. So let's go on and solve for theta. To solve for theta, we're going to have, this value is giving us 1000. It's now equals to V naught squared. What is V naught? V naught is 144.0 squared. And then multiply by sine 2 theta all over what? 9.8. Right. Let's take our calculator and do some mathematics here. So we're going to have 1000 multiplied by 9.8, which that is going to give us 9,800 equals to, let's square the 140, and then let's see, we are having 19600 sine what? Sine 2 theta. Right. What is it from this point here? We want to find this, so I need to divide through by this. So sine 2 theta is now equals to 1000, that is 9,800 divided by 19600. And what are you having? We are having 0.500. Alright, good. From this point here, the knowledge of trigonometry is very important. Look at this here. Sine is positive. So on your here, okay, on this Cartesian plane, we said in this quadrant, all the trig ratios are positive. And here, sine is positive. And then tan is positive here. And cos is positive here. So, I know some people simply say cast, just to remember. But I have a different way that catches student attention and makes students to understand this very well. And that simply means that what? All stupid teachers complain. So we can see that here, all stupid teachers complain. So in the first quadrant, all the trig ratios are positive. In the second quadrant, sine is positive. And third one, tan is positive. And in the fourth one, cos is what? Positive. What does this mean? This simply implies, like, if you look at this equation here, sine is equals to positive. That means that it is possible that we are going to have this angle in the first quadrant or in the second quadrant. So if we have it in the first quadrant or in the second quadrant, then we can calculate for this reference angle here, and that reference angle that we will have, then we apply the coefficients to that and find the final values. So if you do this from here, this is just going to be 2 theta is equals to the what? The arcsine of 0.500. And if you do this straight away from this point, as I said to you, we will be having two values. So we'll be having 2 theta to be equals to 30 degrees or 150 degrees, according to the coefficients in the first quadrant and in the second quadrant. So we have it like this. And now what we want is not 2 theta. What we want is what? Is theta. So what do we do? Theta is therefore equals to, if we divide 30 by 2, we have what? 15 degrees. Or Let's divide 150 degrees by 2, that will give us 75 degrees. Therefore, this is the angle in which the cannon should be what? Should be placed in order to be able to do what? In order to be able to hit the what? The target. Alright, so now let's solve the next question. The next question says, a football is kicked from a ground level T at an angle of 37.0 degrees with an initial velocity of 20.0 meters per second. Calculate the following. And the first one says, calculate the time taken to reach the maximum height. Right. So we want to find the time taken to reach the maximum height. The ball is kicked from a ground level T. So we can see that here is what we have, and this ball is kicked from the ground level, and the ball goes up and the ball then returns back into the ground like that. So this is what we have, and we can see that there is initial velocity that was given, and that initial velocity is given to be what? 20 meters per second. So our V naught is 20.0 meters per second. And we were told that an angle that is made with the ground is 37.0 degrees. 37.0 degrees. These were the information that we were given, and we are taught to calculate what? The time it will take the ball to reach the maximum height, which the maximum height is here. Right. What we know is that the maximum height, we are going to have the final velocity of the y component to be equals to 0. Okay. So if the final velocity of the y component is equal to 0, then what is going to be the what? The time it will take to reach that height. Right, let's go on straight away. That is our first question. So if we want to solve this problem, we know that the acceleration is 9.8 meters per second squared. So once I have this problem like this sketched and I want to solve, I can use the equations of motion. V y f is equals to Vy initial plus GT. And because I want to go to the vertical component, since I am moving in a vertical direction, Vy f is now 0, and Vy initial can be calculated from here. So we can just simply say that this is Vy f is equals to V naught sine theta plus GT. Right. Now let's do the substitutions and see from here. This is 0 is equals to V naught is 20.0 multiplied by sine what? Theta, and theta is 37.0 plus, what is our G? It is negative 9.8 multiplied by the T. Right, because I've taken my upward motion as positive to have this. From here straight away, all that I'm going to have is T is now going to be equal to 20.0 multiplied by sine 37.0 degrees divided by 9.8. And what is going to be our T? Okay, let's take the calculator and then let's see what we're going to have. If I punch this, okay, so this is 20.0 multiplied by sine 37.0, and now I am dividing that by 9.8. And what am I getting? I am getting 1.228193925 seconds. Right, switch, I can just write it into 2 decimal places and have it as 1.23 seconds. Right, so I have 1.23 seconds as my time for me to reach the what? The maximum height. Okay. Once I have gotten this, this is the time to reach the maximum height. Which is the first question that we are told to calculate for. I've gotten that time. What is the next one? The next question says we should calculate the maximum height the ball reaches. The maximum height this ball is going to reach is from here to here. So this is what we are looking for. We are looking for this displacement. And remember, this is in the vertical direction, so that's going to be change in y. So if I have these, what are the informations that I have? I have initial velocity, I have my acceleration, I have the angle given to me. Now I know the time to reach the maximum height. I can just simply find the displacement, because we want to look for the displacement. And if I want to look for the displacement, let's see, from here to this point, we can look for our change in y for that direction as well. And if I'm looking for the maximum height that is going to be reached by this ball, then I need to find the total time it will take the projectile to reach the what? To reach the ground. So I can find that total time that it will take it to reach what? To reach the ground. And once I know that total time it will take it to reach the ground. Let's see what we want from the question. Sorry, let's check it out again. The maximum height the ball reaches. Right. So I want to find the maximum height the ball reaches, and that means that I'm from here to here, which is just the same as this. And once I know the time to reach the maximum height, I can find the maximum height itself. So if I want to do that, because I know the time that it took me to reach that side, so I can find the maximum height itself. And if I want to find the maximum height, I can simply just look at it and say, okay, Vf squared is equals to Vi squared plus 2G change in y. And that will help me to find what the maximum height, because I know the final velocity at the maximum point, I know the initial velocity there, and I know G, so I can find this. Right. If I know the total time, I can also make use of the formula that is change in y, okay, to be equals to VIT plus half GT squared. And that means that if I want to use this formula, I need to find out the total time that it will take from here to reach the side. And after knowing that time, then I will be able to do what? To find that. Okay. So from here, I want to make use of this formula. What is my V final? Here it is 0, so I square that. The V initial is given to me still as this. So that is my V naught sine theta squared plus 2G change in what? Change in y. And I want this, so that is going to become what? Change in y to be equals to V naught sine theta all squared divided by what? Divided by 2G. And in this case, I have taken G to become what? To become positive. So that I will substitute the values. Right. So let's do that quickly. I'll say that change in y is now equals to 20.0 multiplied by sine what? Sine 37.0, and I square that and I divide that by 2.98. And then let's see what we're going to have. If you work this out by our calculator, let's press that value into it. And if you press on that value which you have straight away, let's check it and see what we're going to have. Okay, good. So once we press that, we're going to have 7.3914. Okay, I can make it 15 into just meters. And then in 2 decimal places, it will be 7 point what? 7.39 meters. 7.39 meters. So this is going to be what? The maximum height. Okay, the maximum height that the ball is going to reach. So from here to here is going to be what? 7.39 meters. Right. As I said to you, we can find the time, okay, that it will take the ball to do what? To reach the ground, and then we will use that as well to calculate for what? To calculate for the change in y, and we should have that value as well. Okay, let's look at the next question. The next question says the total time the ball is in the air. The total time the ball is in the air. So that means that we are now calculating for the whole time it will take the ball to do what? To reach the ground. The whole time it will take the ball to reach the ground. So once we are looking for that, there are two ways we can do that, but the right way to get the exact value, because we don't know the examiner's mind, is for us to use this formula, and then we'll be able to find the total time. Another way we could do was that from here to here, if it is taking you this time, then from here to here is also going to take the same time, because this is half of that time, this is the half of the journey, and half of the journey. So the time it will take you from here to here should be the same time it will take you to reach the ground here. So we can just simply, as we have found this from here to here, we can multiply that by 2, and that should give us what? This one as well. Alright, so we could just multiply this by 2, and that will give us the answer that we are looking for. But to have the exact value, the appropriate one, let's make use of this formula and then work it out and see what we're going to have. Right. So our question C, we make use of change in y is now equals to v it plus half gt squared. And what we are looking for is t squared. So if I'm looking for t squared, what is the value of this? We have calculated that, and we got what? We got 7.3915. So 7.395 meters. Remember, I am looking at it from here to here, so I'm going to look at it as negative value when it is coming down. So if you go by this, here I'm going to change the, now it's coming down, so the displacement is now going to be negative value, and we have calculated for that. So I'm going to use the 4 decimal places 1 to get actual value. So it's going to be negative 7.3915 is equals to, this is 20.0 multiplied by sine 37.0 degrees multiplied by the time, which is unknown to us, plus half multiplied by negative 9.8, and then multiply by t squared. And now I can now solve for what? For t. Because we want to look out for the total time to reach the ground from there. So once I have this, let's check it and see. This is going to give us this one, same thing. And from here, we're going to have, I want to use the actual value. So let me maintain this again. Plus, what are we going to have? Okay, let me just punch the calculator. I'll leave it in 4 decimal places so we get accurate result. So this is 20.0 multiplied by sine 37.0. Okay, and this is going to give us 12.0363. Okay, t plus, okay, this will become minus because this is half multiplied by that. That will give negative what? 4.9 t squared. And I would transpose everything to this side because I want this t own to become what? Positive. So I will have what? 4.9 t squared minus 12.0363 t, and then minus 7.3915 equals to 0. This is quadratic again, and we can make use of the quadratic formula, or you make use of your calculator and then you solve for that. I'm going to use the calculator to find my answer straightforward from here. So if I go to equations, then this is quadratic, so I pick number 3, and the A is 4.9, and then my B is negative 12.0363 equal to, and then my C is negative 7.3915 equal to, and now I can see my answer is out. T is now equals to 2.9651, or it is what? Negative 0.5087. This is in seconds, okay, and this is also in seconds. Now, which one should be the correct answer? Our time will not be negative. Our time is going to be what? Positive. Therefore, we'll say that T is now equals to 2.917 seconds in 2 decimal places. So we've gotten our time, the total time that the projectile is going to spend in the air, to be what? 2.97 seconds. If we have used the time that we got before to multiply that, you'll see that the value is going to be around 2.46 seconds. That tells you that there's a difference there, and that's the reason why I said the right way to go by that is to use this formula to solve for that. But it depends on the examiner who sets the question. He may give what? The range, and then that value will also be accepted as well as what? This value. Right. Let's look at the next question. The next question says, how far away from the kicker the ball hits the ground? How far away from the kicker where the ball hits the ground? So how far away is that? The kicker was here, okay, that was a gentle guy who happens to be here, okay, and he kicked the ball, okay, so the ball now is now from this point, and now it is here in the on the ground. So what we are looking for is to look from here to here, which is the what? The range. So we are looking for the range in this case, and to look for the range, which is the same as what? The change in the x, because it is in the what? It's in the x direction. Okay, so if it is change in x that we are looking for, what is it going to be? Our change in x in that direction, our formula that we need to make use of, we know that the range with this change in x is now equals to v, what? X initial multiplied by t. Which t? Total t. Because now we are here on the ground, so that is the total t that we are looking for. Right. So what is then going to be? Our change in x is now going to be v change in vxi is now what? V naught cos theta multiplied by what? The total time. Good. And that means we are going to have what? 20.0 multiplied by cos 37.0 degrees multiplied by what? The time. And what did we get for our time? What did we get for our time? We're going to use that positive value, and that is 2.9651. Right, I'm using the 4 decimal places to get accurate result. So let's see what we're going to do. Let's punch that into the calculator, and let's see what we're going to have. So this is 20.0 multiplied by cos, what? Cos 37.0 multiplied by 2.9651. Right, so what are we getting in all? We are having 47.36068302. Okay, so I'm writing my final answer in 2 decimal places. That is 4.7.36 what? Meters. So that is the what? The distance that is going to cover from the point where it was what? Projected to the ground. Okay, to where it landed. So from here, the kicker's place to what? To where it landed. It's what? 47.36 what? Meters away from that. Alright. Thank you very much for watching this video, and please, if you have not subscribed to our YouTube channel, do so by clicking on subscription, the red button that is there. Just click on that, and if you click on it, click as well on the notification bell, so that anytime we release any new video, you'll be the first person to watch it. Please, as you subscribe, share the video that you are watching to your friends so that they can also watch them. Like the video as well. Give your comments. For those things are the things that will keep us going. It is very important to us, and we need them in order to improve on our channel. Alright, what I will say to you at this junction is that keep on learning, for learning is life and life is learning. I will see you next time. Bye bye.